Hi Year 12s! In this video, we will look at how we can algebraically solve trigonometric functions. This is important to know since it usually appears as a question on the first Math Methods exam. As we've learnt in the compound and double angle video, a sine or cos function can either have infinite or no solutions to an equation. Therefore, we will always be supplied with a domain over which the questions ask us to find solutions. This will only require us to find a finite amount of solutions. For the basic function over the domain of 2 pi, there will be two solutions to each equation, unless we are asked for a maximum or minimum point. The tan function will always have one solution over its period, but that period for the basic function is pi. Therefore, step 1 is to identify the period length, as that will tell you how many solutions you will get. Step 2 is to solve the equation by taking the inverse of the trig function to the other side. Step 3 is to determine what the other solutions are over the domain by adding the appropriate amount of radians depending on the function. This can be the trickiest part. The common convention is inverse cos gives an answer over the range 0 to pi, and inverse sine and inverse tan give an answer over the range negative pi over 2 to pi over 2. Once we have the answer within these ranges, we just need to add or subtract a portion of the period to get the other solution within that range. If we add a whole period, then we will get another solution. That can only be used provided it is within the required domain. Let's look at an example. Solve the equation sine x on 2 equals negative a half for the domain 2 pi to 4 pi. So step 1, determine the period. The period equals 2 pi over a half, which equals 4 pi. It is possible for us to have either 1 or 2 or 0 solutions to this equation. Our second step is to solve the equation. X on 2 equals the inverse sine of negative a half, which, if we remember our exact values, is equal to negative pi on 6. We know that sine is negative in the third quadrant as well as in the fourth, where our answer is from. Therefore, the value of the inverse sine on that half is negative 5 pi on 6. Then we times both sides by 6 to get negative pi on 3 and negative 5 pi on 3. Neither of our responses are in our domain. However, they are still answers to the equation. In order to get them into the correct domain, we add the period of the function, as we know they occupy the right spots on the unit circle, but are just in the wrong cycle. So we add 4 pi to both the responses and get x equals 7 pi on 3 and x equals 11 pi on 3. These are both in our domain of 2 pi to 4 pi, therefore we have our answer. It's very easy to lose marks by not translating our solutions to the correct domain, so you should always ensure that you find the two different points on the unit circle before adding the period to place them within the correct cycle of the function. Good luck with your studying!